Hello friends, myself Bala. Today we see about MongoDB introduction. Before starting MongoDB introduction, let me brief about how this tutorial series going to be. Instead of just explaining theory, more of hands-on implementation, you will really find end-to-end implementation of MongoDB in real time. Especially this tutorial series is designed by intending not only like a database administrator but also for developers and even who is freshly looking for job first time in IT industry or someone shifting their career to big data. So for everyone this tutorial series going to help. And what are the things you are going to see in this tutorial series? Like couple of things. How to improve performance of cluster by sharding and or by indexing. How to optimize the cost of MongoDB cluster. In your day-by-day activities, how to debug and troubleshoot issues with database operations, and which all are the tools available to debug, and what are the various ways to debug. These are the various things you will find in this series. So before starting, let us see agenda for today's session. So types of databases, as you see, like there are especially two types of databases available: relational and non-relational. So along with comparisons in various prospects like usability, cost, use cases, drawbacks, along with what are the different NoSQL database types available. So everything we will see in this session. Let's start with relational. This one you will see in your studies time. So relational meaning. So before going there, let us see how data gets stored in database systems. So in our real life, we see students or customers or employees or banking transactions. We see so many, right? But this data, how it's stored in backend databases. Let us take by example. So if you take e-commerce application, so e-commerce application, if you think customers will be there, the customers will be placing the orders. So if you think about this data need to store in database, we need to come up with tables, right? So how you design those tables? Let us see uh, for a customer and orders who is going to place. So there are various fields or columns you're supposed to come up with, like customer ID, first name, last name, email, whatever you're seeing over here, along with order details. Let us take an example. One customer is placing 10 orders. So normally we may come up with one table. So if we are managing one table all this data, how we are going to store? as an example, so customer ID, George, Washington, address, his city, state, zip code, and here it continues. It continues like order ID, order date, amount, customer ID. Let us suppose, as I mentioned, he is having 10 orders. So 10 rows of data you will come over here. So 1, 2, 3, 4, 5 with how? So 1 George, Washington. So this row of data whatever you are having, first row along with his order details gets appended over here in the right side. So for the first order and for second order again this repeats first name last name and these basic details along with second order details. Similarly this detail this first row of data repeats 10 times and order details gets vary. If you maintain like this, you are repeating lot of data. It's really not needed, right? So what you will do, instead of managing all the details in one table, what you do, you will divide it into multiple tables. In this scenario, customers and orders we come up with. So the idea over here, instead of managing one complex table, you will divide it into multiple tables like customers, orders, social profile, whatever it is like. But how to fetch data from these various tables? Meaning we should maintain some relation. You see over here customer ID, you see customer ID over here and here also, right? So that means we will be maintaining some relation between those tables, meaning like through primary key or foreign key. So like that you will be maintaining some relation. So that is the reason you are considering this as relational databases. Okay, so especially in real time, if you think about students within a college or university or employees within IT industry or whatever the organization it is, or banking transactions or e-commerce applications, simply we can say online transaction processing kind of applications, you will be using relational databases, and especially relational databases maintaining millions or couple of billions records. Okay, so far is good. Why you needed non-relational, and especially where do you use? Meaning, if you think about social media like Facebook, Twitter, trillions of messages people will be posting, right? And if you think about relation between those posts, it really does not matter, right? And how that data, like if you see like Facebook or Twitter, millions of billions of users will be using, but those are very good, right? You never face any performance issues. How it happens? So that is where like non-relational databases come into picture. There is no relation between data. Okay, so those kind of scenarios, NoSQL databases will be helpful. So one scenario, if you think about social media like Facebook, Twitter, LinkedIn, or WhatsApp, whatever it is like. Another scenario like IoT sensors, like weather. How you will get weather in your iPhone or wherever it is like. So normally company what it does, it will be setting up some sensors across various locations. Those sensors will be sending the data to your application, and that application gets tracked and displayed over here in your Apple iPhone app. Similarly, temperature also. So that company feeds various temperature sensors in various locations. So those temperature sensors will be sending data, and the data gets displayed. If you think about, there is no relation needed, right? So here is where NoSQL databases come into picture. Okay, I hope you got a very high level understanding of relational as well as non-relational, very high level. Okay, so now let us go little bit in detail about relational. How exactly, where exactly you will use relational, what are the different characteristics. In order to come up with relational databases like Oracle, MySQL, like SQL Server, whatever it is like, relational databases especially needed some schema. Means before utilizing your database or tables, you should have some schema. Without schema, you cannot use. And schema means structure, like various fields. If you think about employee, employee ID, employee first name, employee last name, employee address, kind of stuff, should be well known before creating tables. So once you create tables, cannot be altered. Okay, so that's what this point I already covered. Table structure needs to be well known in advance, especially in case if you need to change the structure of the table, you can do, but it's going to be very complex. And more importantly, relational databases are licensed. So you cannot use without purchasing license. Even though you have some databases like MySQL, you may use for testing purpose, but most of the databases like relational, you should purchase license. These are the various things if you think about with respect to relational databases. If you think about non-relational databases, those are open source, completely open source, unless enterprise level. So in order to use NoSQL databases, you really don't need schema, completely schemaless. And that's to dynamic schema you can define. I mean, whenever you needed additional rows, you can add. And NoSQL databases majorly stores data in the form of key value pairs. Another way, also like columnar storage. So the storage types you are going to see in later pages, but at this time you understand NoSQL databases how they store data in the form of key value pairs. And even like JavaScript object notation, another way like bison, binary JSONs. Okay, so JSON is nothing but JavaScript object notation, that is one template, one format kind of stuff. Bison is nothing but binary format of JSON. You are going to see how exactly it looks like, but at this time you remember binary format of JSON is nothing but bison. So non-relational databases follows simple query language In case of relational databases, it's like SQL, you call it as structured query language, but here it's a simple query language. And the name, how you got MongoDB? If you think about the first letter M, meaning mean stack. So MongoDB especially developed by intending this mean stack. So what exactly the mean stack? So first letter, as you know, mean stack is nothing but a collection of JavaScript based technologies. You know, Java is a backend and JavaScript is a front-end UI. So that is where JavaScript they come up with. But there are various frameworks today available like JavaScript based technologies. So those are nothing but MongoDB, Express.js, AngularJS, and Node.js. So there are various JavaScript based technologies available in the market today, but especially MongoDB is developed by using mean stack, meaning these are the four JavaScript technologies. So that is what you mean a mean stack. So by taking example, let us suppose if it is relational database, how the data gets stored. If you remember, relational database meaning if you want to use data structure should be well known, meaning like the student number, student name, or whatever the columns should be predefined. Let us suppose if we needed city, let's suppose in future you need to add another column like city. It's very hard. Okay, the reason if you add that data for the specific column also needs to be added for all the existing rows, right? So there are ways what you can do. You can create a new table, move the existing data to new table by appending additional column. So those are complex operations. It's possible, but it's going to complex. So this is how it gets stored. And difficulty, if you were not designed or developed your table before starting up with. So how, let us suppose your application need to fetch data. How exactly internally it works? So it will go sequentially. So every row, every column, it will scan and look for your required column and gets pulled and display over there in your front-end application. That's how internal architecture of your relational databases. Okay, so I mentioned relational databases, especially online transaction processing applications you will be using like banking transactions or e-commerce applications or employee tables, kind of. If you think about, so those tables will be having millions of rows, not going to be complex. But social media, if you think about, per second, trillions of messages gets generated, right? Trillions of messages especially. So that kind of data you need to store, process, and produce result. Means those many columns, those many rows, trillions of rows you need to scan means going to be very complex for the hardware resources. So high computational hardware resources really needed. Even whatever the level of hardware resources, advanced hardware resources available today in the market. Even though you purchase advanced technology, still going to be more complex if you don't design your table structure or database well formatted. Okay, so it's entirely different if you think about columnar databases. So let us suppose to student table again, but just as an example, how it's going to work in background. If you think about, is entirely different. So let us suppose if you needed a student name and student age, other columns completely it ignores. So it just look for student name and student age. Let us suppose this table is having, let us suppose your Twitter post. How many columns it will be having? There are a couple of hundreds even, right? Tens or hundreds. So all those columns is going to skip means how better performance it is. Just think of. But this is not the scenario in relational databases. Okay, so this is how it scans the data and produce the result. This is how your non-relational database is designed. Another thing, if you think about how the data gets stored internally in relational and non-relational, if you think about, so this is especially how data gets stored in backend databases. So if it is relational, let us suppose these are the four columns you are having. Internally, how it stores, this is how: first record, second record, and so on. Keep continue like this. Okay, so but if you think about non-relational databases, so it's entirely different. See here, student number, student name, like this is going to store. How is really going to help? Let us suppose student number, you were given size like 25, student name 35. So, but in real time, student number, even though you were given 25, you may not give 25 size, right? Size limit, right? So, here you have given just 4 bytes, 4 characters, but still it's going to store 25 character range in NoSQL, sorry, in relational databases. But in NoSQL databases, how it's going to store? If you were provided 4 columns, just 4 characters wide, it just stores. Meaning, even though you were given size of 25, but just taking 4 characters, 4 bytes range, remaining 21 bytes is saving, right? Like that, if you think about, you are going to save lot of space. So it's not only saves your storage costs, it also helps in improving your performance. Okay, so as I mentioned, like this columnar store not only helps like reducing your storage size, but also improving the performance of your applications. So that is the main intention of NoSQL databases, and the data store entirely different compared to relational databases. Okay, and okay, in another screen you will see, but what I mean now, in NoSQL databases, in real-time Twitter, Facebook, this kind of applications, if you see, there are trillions of messages. So, how much space you are going to save, just think of. So, that is where columnar store come into picture and will be helpful. So, especially if you think about non-relational databases, where exactly it will be helpful. Let us suppose hotel reviews. You're adding review, you search for Google and you visited some place and booked some hotel. Once you're done with your visit, you want to add a review. So, that hotel review. What are the various columns you may provide? Here are a couple of things I came up with, but there are a lot many, right? So, locality, complimentary breakfast, whether they are providing free Wi-Fi or not, snacks, kids play area, like so many things. If you think about, are you really going to use all these columns while providing review? How many people follow this logic, like all the fields they provide while writing the review for a specific product or specific hotel or whatever it is like? Not really, right? All these columns are not mandatory. So some columns you may skip, but I mentioned you may skip some columns, but this is not possible in your relational databases. Okay, so in relational databases, your table is having 10 columns means you should enter values for 10 columns, but that is not the case in NoSQL databases. Meaning, if you have 10 columns or 20 columns means you may partially fill up those fields and provide your review. So that is what that is where the benefit you will see with your non-relational databases. So non-relational databases also you can call it as NoSQL, meaning not only SQL. So as I mentioned earlier, hotel name, locality, swimming pool, you may enter. Now you design your table with just 3 columns, let us suppose. Tomorrow, another record you want to enter, whatever the column it is like, complimentary breakfast. Yeah, anytime you can alter your table and enter value as well. This is the advantage of NoSQL databases. What I mean, initially the table design you are having 3 columns, but in future you got requirement like need to add another column. You are good to add another column and value for the specific column also you can provide. And another important thing, as I mentioned earlier, if it is relational database, all the values for all the columns mandatory. But in non-relational database, that is not the case. For some of the columns, you may skip values. You see here, for this hotel, you are just providing 2 columns. Even though you are having 4 columns at this time, but you are providing values for just 2 columns like hotel name and locality. Similarly, at any point of time, you can come up with more columns. That is the advantage of NoSQL databases. And another important thing, the values are not mandatory for all the columns. Okay, so far you have seen relational as well as non-relational databases, how the data structure varies between those two databases. Now we see NoSQL database types. Okay, so don't get confused. In NoSQL databases, again, there are various types available. So those are nothing but wide columnar databases, key value store databases, graph databases, and document databases. So in NoSQL databases, these are the four types of databases available. Again, we are going to see what exactly are these databases, NoSQL databases. So columnar. In columnar databases, so this is how data gets stored as you see in the image. So row key, column, like name, value, timestamp. So that's how it gets stored. Examples for columnar databases like Apache HBase and Cassandra. These are the familiar tools and follows the data structure like columnar databases. This tutorial series is especially designed for MongoDB, just giving you idea about history about NoSQL databases, what are the databases available. If you really want to know internally about these tools, you may watch for other videos. If I take up explaining these tools, it's going to take a lot of time and really time won't permit us. So that's the reason I'm just giving you idea very high level, but the intention of this video is like providing very high level idea, not in detail. So key value stored databases, if you think about exactly like this, it gets stored key and value as see over here. So key value databases, table customers, if you think about row ID, key, see row ID, key, exactly like this, it will get stored here. Another one. Key value store databases, especially Redis and Amazon DynamoDB. So Redis is like in-memory database. You know memory, right? In your computer, you will have RAM as well as hard disk. Hard disk data gets stored permanently, but memory means for processing only, for temporary storage. Means temporary storage means for past accessing. More memory you are having means your computer is that much performance, right? But Redis is especially designed like in-memory databases like better performance. So that is where Redis come into picture. Even another one, Amazon DynamoDB. So DynamoDB also like a key value stored database example. So another database like Graph. Graph databases especially useful in like in our real time police department gets used graph databases like finding out uh, like what do you say thefts and so many things crimes kind of stuff happens in our real life, right? So many will be seeing, right? So to find out those kind of things, graph databases will be pretty much helpful. Neo4j, OrientDB, Titan, these are the some of the examples for graph databases. And another one, very important thing, document database. So MongoDB comes under document database and data gets stored in the form of JSON files or BSONs as I mentioned earlier. So MongoDB, Couchbase and Cloudant are examples for document databases. See, these document databases, especially where do you use in real time? That's what you're going to see in later sessions, I mean later PPTs. But as of now, you do remember MongoDB comes under like document database. Okay, so we see little bit use cases about relational databases. I mentioned I think already, but let us see little bit more. So relational databases especially useful for online transactional processing systems like banking or e-commerce applications, and especially as I mentioned couple of times, millions of rows, couple of billions means you will be able to handle and go with relational databases and complex queries as well. It handles, meaning I mentioned earlier, if you remember, like one instead of coming up with one big table with more columns, what you do, you can divide it into multiple tables, and in order to keep sync up with those tables, you will maintain relation with the help of primary keys or foreign keys. So how you divide those, one big table into smaller table? There are various ways. If you remember, like first normal form, second normal form, third normal form, normalization techniques are available. If you needed to know more about, you may watch for other videos, but just providing very high level idea. So one big table, you need to divide it into multiple tables, means you will follow normalization best practices. When you are using multiple subtables, when you need to fetch data from those multiple tables, what you do, you will use like indexes or joins, couple of things available, couple of options available, aggregation kind of stuff. So there you need to handle complex queries, right? So that is what you will be able to handle. Even transactions you will be able to perform. This kind of complex queries and transactions not extensively supported by your NoSQL databases. Okay, so NoSQL databases meaning no relation between tables, right? So that's how real-time scenarios. If you think about Facebook, Twitter posts, especially there is no relation between tables kind of stuff. So that's where you will use. So even you don't get a chance to come up with complex queries like giants or kind of stuff. Okay, but relational databases were designed by intending these features. And another important thing, relational databases follows acid consistency, meaning atomicity, consistency, isolation, and durability. Each and everything you will see in future PPT, but at this time you remember acid consistency model relational databases follows. So non-relational databases. So especially if you think about non-relational databases, as I mentioned a couple of times, social media, even IoT streaming. What is IoT? Internet of Things. I mentioned a couple of times like sensors, gas sensors, even temperature sensors, streaming sensors. Like there are various IoT devices available. So those temperature devices keep sending data to your wherever you are storing, like S3 or NoSQL databases, or you need to process them and get stored in NoSQL databases. So that's where. So especially there extensively you are using NoSQL databases, even in big data industry, along with geospatial. If you think about Uber, even Lyft, Ola, so these are the various sharing car transportation services. If you think about, there also like especially NoSQL databases they were using, digital communications, gaming domain. So here also like NoSQL databases getting used even fraud detection. If you remember the graph databases, Neo4j, so that database especially designed by intending fraud detection along with mobile applications, gaming I mentioned already, leaderboards. In gaming you will maintain leaderboards, right? Even that is where NoSQL databases. Another important thing, advertisement. Advertisement agencies also try managing using NoSQL databases. Newspapers also, if you think about. So these all are the various scenarios you will use NoSQL databases. And if you think about Times of India, sorry, it's New York Times. They were store they were archived their data since, I don't remember exactly, but it's like 1700 sometime. So that time onwards they were archived their data. So that is where NoSQL databases will be pretty much helpful, just as an real-time scenario. And search engines also keep maintaining NoSQL databases. Advantages: works very well with structured, supports ACID, and giants. I mentioned already, limitless indexes. So how indexes will be helpful in improving performance, you're going to see in future sessions. But in relational databases, there is no limit to use number of indexes, and especially OLTP and data integrity intensive. So meaning while inserting data, you may restrict data, meaning date you are entering, date of birth, especially in that format only should be allowed. Boolean values like true or false, especially, or for age you need to restrict only allowing numbers. So that kind of integrity validations you can implement. Disadvantages is like, okay, if you are new to big data, you might not be aware of scaling. But if you are into big data, you will be very frequently hearing like scalability. So there are two types of scalability: horizontal scaling and vertical scaling. Vertical scaling means small computer, you are upgrading it into big computer. You have one, sorry, 500 GB RAM, 500 GB disk. So you are making improvement to 1 terabyte. That means size you are increasing. Let us suppose you are having 16 terabyte RAM. You need more performance means 32 terabyte RAM, sorry, 32 gigabytes RAM. You may increase it. That means smaller pieces you are upgrading it into big. So that is not, that is nothing but vertical scaling. The relational databases especially supports this vertical scaling but not horizontal scaling. Okay, what is horizontal scaling? Okay, today the advanced technology, whatever it is, so you will have some limitations. Up to some extent, you can increase one computer PC, right? One computer, like 16 virtual CPUs, whatever it is like. But once you reach, you are n- not allowed to scale vertically. That is one thing. And another thing, you need to scale your technology vertically, meaning going to be very expensive. So instead of vertical scaling, what you can choose is horizontally you may come up with another computers. So in this scenario, 16 gigabyte RAM and 500 GB disk. That one, if you needed requirements, you are increasing it into 32 gigabit RAM and 1 terabyte disk, right? So instead of that, what you can do, another PC with same configuration you can add. So that is nothing but horizontal scaling. Okay. So what is the advantage? So if you scale vertically, going to be very expensive, but if you scale horizontally, it's cheaper. So that's what you will understand in future PPTs. But as of now, just an idea, very high level idea. So, and the another advantage is like there is no limit. In big data industry, the buzzword is like cluster. So you can use in AWS especially, you can use there is no limit. I think millions of computers you can scale horizontally, but vertically you cannot scale that much. Okay, so this is another disadvantage. So it's going to be expensive, and it's especially well structured data you may work with for relational databases. Very difficult to work with unstructured or semi-structured data. Even you cannot get stored, you cannot scale up. You can scale up, but you cannot up to some extent, but not limitless. So millions or billions of records, there is a limit. If it exceeds these records count, it's really complex. Another thing, cannot store images or blob kind of stuff or even multimedia products. So that is where non-relational databases come into picture. So no need to maintain structure. Whatever the structure you need, you can come up with. So document databases, especially large volumes of data, structured, unstructured, semi-structured data you can store. Object-oriented programming, that is easy to use. Even scale-out architecture, as I mentioned earlier. Scale up means vertical, scale out means horizontal. Okay, so scale up means vertical, scale out means horizontal. Scale out means horizontal. Don't get confused. So vertical means increasing the size. Horizontal means adding another computer parallelly. So horizontal. Okay. So efficient scale out architecture, MongoDB or NoSQL databases provides so massive data stores, terabytes of data. Uh, Relational databases good as far as gigabytes and terabytes, but you cannot exceed more than terabytes. Okay, so petabytes, even exabytes of data you can store using NoSQL databases. Both it supports like scale up and out, but relational databases supports just scale up vertical scalability, but does not support horizontal scalability. So in case of NoSQL databases supports both, and cost also very cheap compared to relational databases. The commodity hardware try using for NoSQL databases, so commodity hardware is pretty cheap. High availability. So as you know, if you purchase electronic devices, it's like you are not sure how long they work. Anytime they may break up. So let us suppose banking transactions you are using. While you have urgency, the system does not work. You will feel very bad, right? That is very bad user experience. But that one should be tolerated like with the help of high availability. So how the system's design internally is like by chance the systems gets break means other systems gets up automatically. So that is where high availability come into picture. So these NoSQL databases designed such a way like high availability fashion. But relational databases also provides high availability but not this much extensive. Schema free, we already discussed. Speed due to not having joins. This is another important thing. NoSQL databases supports joins up to some extent, but not like limitless. If you really needed joins, you can use it, but up to some extent. And these are speed because of like you don't need to fetch data from multiple tables. So these NoSQL databases are going to be very fast. Less support since yeah. So disadvantages if you think about and another important aspect with NoSQL databases, those are open source, meaning you can use it. You don't want to purchase license. So open source meaning less support you will get from companies. Companies may provide paid support, so that's going to expensive again. So that's where like less support. Administration is lot. If you think about relational databases, most of the features they will be providing administration going to be very simple. But as these NoSQL databases are open source, so administration going to complex, eventual and as you know, relational databases follows acid consistency model, but that is stronger consistency model you can say. What exactly acid? I'm going to explain in next PPT, but at this time acid consistency followed by relational, base consistency model followed by NoSQL databases. That's what you remember. Limited support of giants or does not support giants, less mature. It's not like matured databases you can say. And really, if you think about relational databases were there since 1970s, but NoSQL databases, if you think about just 5 or 6 years or 7 years, very recently these databases getting familiar. So that's how like you can say NoSQL databases are less mature. At 10 or 15 years you can say max. Limited transaction support. So data integrity must come up in the form of code, but no built-in data integrity. Limited indexing. This one we already discussed. So these are the disadvantages of NoSQL databases. Now we see ACID. What is ACID consistency model? ACID meaning atomicity, consistency, isolation, and durability. We go one by one. Atomicity. Let us suppose you are inserting 1 million rows. You were performed that operation and 10,000 rows inserted. By the time something happened, the server went down. What's going to happen? Do you want to store the 10,000 rows or those one also gets reverted? In relational databases, they design such a way like success or failure. No partial transaction. Okay, so it should insert 1 million rows or nothing. but should not be like 500 500 rows inserted and should not be like partial kind of stuff. Okay, so atomicity meaning all data or nothing. So that's how this relational database is designed. So atomicity is nothing but very simple, all or nothing. The transaction should be success or completely fail. So that is nothing but atomicity. Consistency. Let us suppose you are making transfer to your friend. So you initiated transfer like $1,000 from your account to your friend's account. Okay, when you initiate transfer in backend, how it goes is like that $1,000 gets decreased from your account and add to your friend's account, like 2 3 steps it will follow. Let us suppose as soon as you initiate transfer, $1,000 got decreased from your account. By the time something happened, and I mean there are so many things, right? Your computer might went down, internet went down, or servers, company servers got crashed, or whatever it is. Like there are thousands of reasons to get break any of the systems, even database or application or front end application or middle layer. Anything can happen at any stage. What happens? Let us suppose $1,000 when you transfer is got deducted from your account but not added. So that time it happens something. Means it's not going to, I mean, stop that time, right? So what I mean, it should be consistent. Meaning $1,000 as soon as gets deducted from your account, it should go to your friend's account. So before and after, what it does, they will try to check. And another thing, how that systems internally designed, as soon as one transaction initiates, source and destination account, source and destination systems, so they will acknowledge. So transaction failed or success, like that acknowledgements happen in backend. So in our scenario, $1,000 got reduced from your account, but it was not deposited to your friend's account, right? That means it stopped over there. You haven't, I mean, source account, source server haven't received acknowledge at this time. So that means that $1,000 gets deposited back to your account. Otherwise, no one can use banking systems, right? So that is where consistency come into picture. So these transactions should be consistent, meaning both the accounts, whatever the deposits, whatever the balances you are having before and after should get added, meaning like $1,000 or whatever it is like. Okay, before and after executing the transactions should be consistent. So that is what meaning consistency. Okay, I hope you understand. And durability, sorry, isolation. Isolation meaning alone, independent. See, if you think about banking applications, daily millions or billions of people will be using same time. So everyone making their transaction, it should not be impacted other transactions, right? So whatever the transaction you are making should not be impacted other transactions. So that is what isolation meaning means, independent. There is a logical isolation. This one you call it as logical isolation. That means irrespective of the transactions happening, does not get impacted each other. Okay, so those are isolated. And durability. So once you get store your money in the bank account, whatever the case it is, so if you take bank will be using servers, technology, applications. There are various things they are using, means they may encounter failures, right? So whatever the case it is, that is their problem. So if something happens, server got crashed, or application is not working well, or browser is not supporting, there are millions of issues. It does not matter to you. So you are storing money in the bank, means whenever you need, they should give you, irrespective of the failures or issues. That data, that money should be available till you need, whatever the duration it is. Okay, so that is nothing but durability. So once transaction is committed, data will survive system failures or can be reliably recovered after an unwanted deletion. Unless you are going to delete, you put money, you can do anything with that, but nobody else, even that bank manager or bank owner, bank CEO, whoever it is, cannot touch your money. Okay, so or system failures or whatever it is like. So that is nothing but durability. So databases were designed by considering these four consistency models. So that is nothing but acid consistency. So atomicity meaning success or failure, not like partial. Consistency, so before and after executing the transaction should be maintaining consistent state. Isolation, so independent. So even though millions or billions of transactions occurring, should not impact each other. So durability, so how long you needed the data gets stored over there. So that is nothing but durability. So relational databases try following acid consistency model. If you come to NoSQL databases, as I mentioned earlier, follow base consistency model. Base consistency model meaning basically available, soft state, and eventual consistency. Okay, we go one by one. Basically available. Basically available means is guaranteed availability, but what it means, it may not be available 100% of the times. Okay, so banking transactions, if you think about that one should be available 100%. So that is where you are going to use relational databases. But social media, let us suppose sometime the server went down, the data whatever you posted is not available. It doesn't matter, right? It does not impact your life. So that is where you are saying basically available is available but not like 100%. Soft state. So if you remember earlier, I mentioned horizontal scaling. And before going there, the relational databases handles gigabytes or terabytes of data, but non-relational databases handles like exabytes, even petabytes of data, right? So that means huge volumes of data. So in order to store those volumes, one server or one system may not be enough. You will be using multiple systems like primary, secondary. Just remember as of now like primary and secondary, but in future in coming up with sessions you will understand what exactly it is. But as of now you will be having multiple systems for storing these huge volumes of data. Let us suppose your application will be talking to primary server. So backend, whatever the data is available in primary server, background what happens, it gets stored in secondary server as well. So 1 millions of rows you were updated. So whatever the data available in primary may not be gets reflected immediately in secondary servers. Meaning primary there is a lapse in time for getting reflected in both the systems, right? So primary server data may not be available in secondary systems. But let us suppose your system, your application is taking data from secondary. Okay, this is a really huge concept, but at this time I will just give you very high level idea. Uh, these NoSQL database applications, how they design is like primary servers they will be using for writing and secondary servers for reading. Okay, so primary servers are for writing and secondary servers are for reading. Meaning, so as soon as you write data to primary servers, backend to get it reflected to secondary servers, it may take some time. So let us suppose you updated something in primary server, but by the time your application is reading data means from where is fetching data from secondary servers, right? But it's not updated properly. I mean primary server as well as secondary server not synced up. So you may get old data. Okay, so that is nothing but soft state. State of the system can change. But again, if you refresh your browser or something like that, you will get updated data. Okay, so that is what meaning soft state. And that is what I already explained, eventual consistency. Eventual consistency means the updated data you may not get immediately, but couple of seconds or something sometime if you refresh you will get reflected. So that is nothing but eventually consistent. So these NoSQL databases designed with base consistency model. So base consistency model meaning basically available, soft state and eventually consistent. So basically available means data will be available but not 100%. Soft state meaning the state of all of your servers may not be in the same state. So different servers may have different status. Eventual consistency meaning the updated data you may not get, but it may take couple of seconds or something like that. So that is nothing but eventually consistent. So what is the opposite of eventually consistent? That is strongly consistent. Strongly consistent meaning that updated whatever the data you updated immediately it will be reflected. So those are nothing but relational databases. So this is what I planned for this session. Really, if you have any questions, please mail out to this email ID. And really, thank you so much for your time. And I hope this session was helpful. Thank you.